Assalamualaikum warahmatullah. Now we look into the hydrostatic thrust on curved surface. Before this, we have learned on force on the plane vertical space. So let's look into this. Consider an immense curved surface, this one, curved surface subject to water pressure. Okay, so this is the free water surface. So it been immersed in the water. So now we have three force. So now we have force in the horizontal direction, Fx, and then we have force on the vertical direction, Fy, and we also have force as a vector. So for Fx, we know that when we have theta here, so cos theta is the adjacent over the force F, so it will become F cos theta. And then for Y, okay, so we have theta here, so for sin theta we have the opposite over the F hypotenuse here, so it become F sin theta. So when we have alpha here, we have another function here, so it depends on which angle is given. So therefore, to calculate the F force as a vector, we will plus these two, Fx power of 2 plus Fy power of 2, and we need to square root these two. And for the theta, we can calculate by using tangent -1 Fy over Fx, or tangent is the sine theta over cos theta, so we get a tangent. So let's look on how to get the horizontal component. So we have the FH may equal to rho g hg AV. So FH is horizontal force and rho is density, and AV is the vertical projected area of curved surface, and hg is the vertical distance or the center of gravity. And then for vertical component, we will have force, vertical hydrostatic force Fv equal to rho gv. So again, we have density of fluid for rho, and V is the volume of water prism. Okay, and then the resultant hydrostatic force can now be calculated by using Fr equal to Fh power of 2 plus Fv power of 2 the square root. And then we have the tangent theta will give by tangent -1 Fv over Fh. So let's look into this example. So an open tank 6 meter by 1 meter. Okay, so by looking at this figure, we have 3 meter depth. So means that this is error here. So it is, okay, so it is 3 meter. Okay, so this one is 3 by 1 meter in cross section whole water to a depth of 5 meter. So we have a water of 5 meter depth. Okay, so this is 3 meter plus 2 meter, so 5 meter. Determine the magnitude, direction, and line of action. So now let's look into the surface AB. So where is the AB? It is from here to here. Therefore, we have the area of area A 3 meter, and then we have 1 B. So this is the B is 1, and then the depth is 3 meter. Okay, so from this figure, so this is a cross section. So means that when we have 1 meter, 1 meter tu dia punya B lah ya, 1 meter, and then this is 3 meter. So kalau we draw in the 3D direction, so we have like this. Okay, so 1 meter is B and 3 meter is depth. Okay, let's look into this. So we have the what we call rectangular surface. Okay, so B is 1 meter, D is 3 meter, so depth A area is B times D, so we get 3 meter square. And then for height of gravity is at center of the square, so we have half of the 3 meter, so times with the 3, okay, so it will become 1.5, okay. And then force of the resultant, so we have rho g a h g, so rho g is 1000 times 9.81, so we have 9810 times with 3 is the area, and times with the center of gravity is 1.5, and then you get this. And then the center of gravity is moment initial, we have b is 1, okay, b is 1 times d power of 3 over 12, we have 0.75 meter of power of 4. And then we have the center pressure by using the formula Ig sine theta power of 2 over A area 3, okay, times with the Hg plus with Hg, okay, we have 1.667 meter. So settle for surface AB, that is rectangular. So now we move to the surface CD. So which is CD? CD is here, the surface. Okay, so again CD is also the rectangular part. Okay, but at the bottom, so we have area 2 times 1. Okay, area 2 times 1, and then the height of gravity is 3. Okay, plus, actually this is not 2, this is half of 2, so it is half of 2, so 2 over 2 is 1, so some mistake here, so it is 3 plus 1, so it is 4. And then we calculate again rho g a times with the hg, that is 4. Okay, so you get another value here, so therefore hp is so therefore HP we have a formula. You use formula for this one and you get another value. Okay, so we have some error here. Okay, now we need to calculate the surface of the BC. So where is BC? BC is here. So BC is somewhere yang circle ni. So how to calculate the BC? FH, okay, force for the horizontal. So BC is a curved surface, so we need to use force in horizontal and force in vertical. So force in horizontal is rho times G times AV times HG. So where is the AV? So AV is 2 times with the 1. 1 is the depth. Okay, depth. B. Okay, B. Okay, so 2 times 1, 2 meter. 2 meter. So Hg is 3. So we have 3 here, plus with the half of the 2. 2 is the depth, right? 2 from here to here is 2. Okay, from here to here is 2, and then we have half of the 2 is 1, so we have 3 plus 1 is 4. Okay, so for the force of the hydrostatic of the horizontal, we have rho g times with the hg plus with the area. So area is 4. Okay, so we have this one. Okay, settle for horizontal direction. Now we move to the vertical direction. So for vertical, we have formula rho GV, that is volume. So we need to calculate the volume. How about the volume? So we need to calculate the area. Area of this dash area. Okay, so we need to calculate 3 times 2. So we have 3 times 2 is, okay, plus with the 1 over 4. So what is this? This is the formula for the circular. So when we know that the circle is pi j power of 2. So j is 2. Okay, so because we only have this area, okay, so we have to divide into 4. So therefore we get 1/4 pi j power 2 times with the rho GH, right? So H is 1. Alright. So volume, right? So we know that this is the area, and then we times with the depth. Okay, so we can get the volume. Alright, the width, the b is 1, so 1, so we get the volume. Alright, so now we calculate the FV. So we have 182.136 kilonewton, and then we get the resultant force by using this formula, and also the tangent theta by using FV over FH. So you get the theta is at 66.7 degree. Alright, so let's look into this example. We have the magnitude. To find the magnitude and direction of resultant force due to water acting on roller gate. This is a circular cross section, okay, of a roller gate of 4 meter diameter. So we have 4 meter here, diameter of this gate, and then the gate is placed on the dam in such a way that water is just going to spill. So take the length of the gate as 8 meter. The length means when we project it to this direction, so okay, we can use this is the length is 8 meter. Okay, so the diameter is 4. So now look into this. We have Fx rho g ah, okay, from previous formula. So we have area of the AOB. So AOB is this cross section AOB. So we have 4 times 8, okay, is 32. Okay, so therefore area of AOB, so 4 times 8. So when we project the circular, okay, we put it in this cross section. So 4 is the diameter, right, and then the 8 is the length. So 4 times 8 is 32 for this surface. Okay, so now we need to calculate the center of gravity. So 4 divided by 2, we have 2. So therefore the formula for Fx is rho g times the area times the hg, center of gravity. So we have Fx is 627,840 Newton. So let's calculate the force of the vertical. So we have formula for rho g times volume. So what is the volume? So volume is, okay, so you know rho g. Okay, so we have pi j square over 2. So what is pi j square? So when we have the circular, so j is the 4. So j is diameter is 4. So therefore the r is 2. Okay, so this is the r is 2. So times with the 8, the length. So therefore we have 9810 times pi over 2 times with the pi j power of 2 times with the 8 length. So 8, so it becomes 493,104 Newton. Then we need to calculate the resultant force. So F equal to the Fx times Fy. Okay, so we just use this formula and you can calculate the tangent, that is given 31.8. Alright, so let's look into this example. So for this example, we have a radial kit. So here is the radial kit whose face is part of a circle. So this is the part of the circle, okay, with a 30 degree radius. Then it hold the water. This kit is holding the water here, and then as shown in this figure. Okay, so the sector of the circle represented by the gate as angle of 30 degree. So again, this is 30 degree at the center, and then the water stand to the depth of 1.5. Okay, so we have 1.5 meter. okay, from the top of the gate to the surface of the water. Okay, the other side of the gate is open to the atmosphere, so meaning this is open to the atmosphere. And then determine the total resultant force acting on the gate. The width of the gate is 2 meters. Alright, so looks, we will convert this radial gate into this figure, so it become the rectangle figure. So we can calculate the area. So area is 2. So 2 is the depth. 2 is the width. Okay? Width of the gate, 2 meter times with the 1.5 meter. So 1.5 meter is the depth of the gate. Okay, 1.5 meter. And then we get 3 meters square. So therefore, to calculate the height of the gravity, we have 1.5 meter from the above of the surface water to the above of the tank, okay, plus half of the depth. So we have times with the depth of 1.5 meter, so we get 2.25 meter. And then we calculate the force of the horizontal force. So we have rho g AV, AV calculated, and then Hg is that, and then you can get the 66.218 kilonewton. Alright, so now we looks on the curve. Okay, so we calculate the area of the curve. Alright, so we have 1.5 times with the 3 minus 2.598. What is 2.598? So from the sine theta here, we have the theta is 30. So 30 equal to y. Y is the opposite direction over the 3 hypotenuse. So we get the y is 1.5 meter. So y is 1.5. So now we can get the x is by using this formula. So you have x is 2.598. Therefore, this is the 2.598. So now we need to know the distance from here to the gate, alright, to the wall. So therefore, you just minus 3 minus 2.598. Okay, so you have the area for this shaded, yeah. Okay, so now we calculate the area, and then you get 1.0105 meters square. So now we times with the depth, that is 2 meters, so we get 2.021. So now we need to calculate the force of vertical force. So rho g times vertical times volume. So we have the volume 2.021. So we just put into this equation, and we get the resultant force by Fh plus Fv. Okay, so we square root, and then we get 69.122 kilonewton. Therefore, you can calculate your tangent theta by using this formula, and you get your theta 16.7 degree. So you can try this exercise. Alright,